So in this video, we're going to be looking at the send feature in LangGraph. Send. Now, send is used to perform map-reduce operations in your graph workflows, but it would make more sense using an example. So let us assume that you have a node. You have a node, and this node generates a bunch of student scores. So you have, let's say, like a dictionary inside them, or a list of dictionary objects containing scores for each student. Let me expand this. So inside here, let's say you have Mike, and Mike has like scored 60. Then you have another dictionary, let's say Monica, and Monica scored 80. Then you have okay, get this down. Okay, let's do this. Then you have Juan, who got 90. Okay, so you have a dictionary of student scores. And these are generated by this node. This node just generates them or pulls them from the database. So let's just use that. Let's say this node pulls them from the database. And sometimes this database will contain 5 students, sometimes it contain 10 students, and sometimes it contain 50 students based on the class. Let's say you're going from class to class. So let's say in class A, there are like 50 students. In class B, there's 40 students. In class C, there's 70 students. So the number of students, you can't determine it. It's not fixed. The number of students is not fixed. So this graph has to work on different tables for each class. So each class has those student scores in each table. And like I said, one table can contain 50 students or 50 rows, and that table of scores can contain 40 students. So you don't know the number of scores you'll be getting beforehand. But then you have another node that needs to process these scores. You have another node that needs to process these scores. So what the node does is that it takes a student score. The node takes a student score, then calculates their grade. It calculates their grade. So let's call this node calculate grade. Calculates their grade. So let's say anything above 70 is an A. From 50 to 60 is a B. From 40 to 50 is a C. Whatever grading system you want, this node calculates it. And what you want to do, you want to go from this node that gets all the students from the database and go to this node that calculates the grades. But this node can only calculate the grade of one student. So you need to run multiple of it. But you don't even know how many you have to run beforehand. You don't know because like I said, a class has 40 students, another class has 50 students, another class has 90 students. So you don't know beforehand how many students are in a class. So because of this, you need to use map reduce. You need to use map reduce, meaning that you need to be able to spin up as many instances of this node for each student. You need to be able to spin up as many instances of this node for each student. But you don't know the number of students beforehand. And once you're done calculating the grade of each student, you have to prepare it. That's using another node. You have to prepare it in a final report. So let's say this grade is this node is final report. So you need to prepare it in a final report, and you need to combine all the results from all these nodes. So like I said, you need different instances of this node. You need multiple instances of these nodes according to the number of students that come from each table. And at the end of the day, you need to synthesize all this information into here. So what send allows you to do, what you can do with send is that When this node fetches those users, or rather when it fetches those student scores, depending on the number of student scores, you can then use them to generate multiple instances of this node. You can use send to generate multiple instances of this node. Go here, another one. So you generate those multiple instances based on the number of scores you get. And also, they would work on different states. Each of them will work on different states. This will work with Mike. It will work with the Mike object. This will work with the Monica object. This will work with the Juan object, and more and more and more. Dilip, Kwaresh, more and more names that come up. It is going to spin up a node for each of those records. It's going to spin them up for each of those records. So the fetching of the records, you don't know the number of records you fetch, but when you fetch those records, you can then use send to loop over that list and spin up a node each for each record and send a private state to each node. So here you send Mike, here you send Monica, you have Juan here, you have Prakesh here, you have Dilip here. So you spin up as send requests for each of those instances. You spin up send request for each of those instances. And what send does is that a single send request takes the node you want to go to, which in this case is calculate grade. It takes that. Then it also takes the private state. It takes the private state that you want to pass in. Here we want to pass in the score for Mike, which is 60. This is one send operation. So you're going to spin up this for each of the records, each of the number of records. You do it dynamically. You spin it up for each of the records, and send is going to enable you to spin up as many instances of this node as you can and pass in a private state to each of them. And at the end of the day, you can take everything and pass it into this final report node, everything here, pass it into this final report node, and at the end of the day, you can generate a full report. You can generate a full student report on this node. So that's what send helps you to do. You map the operations to as many nodes as required based on the number of dynamic instances that you have. You pass in different state values, values to each of the nodes. It will work on them. Then you can then use your next node to synthesize all those information, to combine, to gather all those information together and prepare your final report. That's basically what send does. It does map reduce for you in your graph operation. And all these instances are going to run in parallel. All of them are going to run in parallel. All of them are going to run in parallel with the private state. And at the end of the day, it will perform the node operation on each of the data that is passed to it. And you can then gather all the data into the state and process them in the next node. How amazing is that? How amazing is that? This is a very, very powerful tool for running parallel operations with different data for each operation. Different piece of data for each operation. You can run parallel operations by mapping to multiple nodes at the same time, but you can't pass in private state to them dynamically. But with send, you can pass in private state to all the instances of the node that are spun up. They both do their calculations, get their values, and you can then bring everything together, your next node. So everything is always clearer and easier with an example. So let us jump into VS Code and see how send works. Now for our demo, we're going to be creating a research agent that takes a topic, splits it into subtopics, and then it will run MapReduce on those subtopics to research them, then bring all the research together. So we're going to be using send to do that. Here in VS Code, to begin, we're going to create a new file. We're going to call it map reduce send demo.py, and here is where the magic happens. So first, let us bring in our dependencies. Say from typing, import typed dict, annotated, and list. We're also going to be using operator as a custom reducer. So from operator, import add. Then we're going to get our graphing tools from LangGraph.graph. So import state graph, start and end. Then finally, we need to import send, and we can get that from LangGraph. Yeah, LangGraph types. Yeah, import send. So that's our send command. So get send. We have all our dependencies. The next thing we're going to do is our state. We're going to create our state. Now we're going to create an overall state for the graph, for the entire graph itself. So we create a main state, our overall state. Then we're also going to define a private state that is going to be used within the send operations. So for each send instance, we're going to have a schema, a state schema for the private state that will be operating within that send operation. So first, let us create the overall state. Say class overall state, sending type dict. Then inside here, first is the topic, the main topic that will be passed in. Then we're going to have a list of subtopics that is going to be like a breakdown of the main topic. We're going to break down into subtopics, and that is going to be a list of strings. And the next thing we're going to have is our research results. This is going to be the result from the research of each subtopic. Like I said, we take a main topic. That main topic is going to be broken down into subtopics. Then we're going to use send to deploy multiple research nodes that are going to research each subtopic. So each of those research results, we're going to have them here. So this will be an annotated, I spelled that wrong. Annotated list of strings, and the reducer is going to be our add function from operator. So this is where we're going to be compiling our individual research. So lastly, we're going to have a final report, and it should just be a string. This is the final synthesized result. Now that's the overall state. Now let us define the research state. That's the state that will be operating in each send operation. So let's call it research state. It will also be a typed dictionary. Now the first key or the first field here is going to be subtopic. This is the subtopic we want to research on. So this is a subtopic from the list of top subtopics. This is a subtopic, the single subtopic we want to research. So it's going to be a string. Then we're also going to put in here research results. We're also going to put research results. This is the same research results from here. And it's just going to be we're going to set it as a list of strings. Now this is the research results from here, and why we put it here is because we want to inside the node that does the research for the subtopics, we just want to append to the research results. So we get that, and we have our state, and then now we define our nodes. Now the first node is going to generate our subtopics. Now in this demo, we're going to be mocking all this stuff, but these are things that are going to be done dynamically, either by pulling them from a database or doing some processing to break things down, or fetching subtopics through an API, or even using an LLM, even using an LLM. So This is something that is going to be done dynamically, but here we're going to be using mock data so that we don't have any sort of dependency. So here we say define generate topics, or let's say generate subtopics to make it more appropriate. So generate subtopics, and for this node, it's going to take overall state, because we're setting the main graph here. It's going to take overall state, and it will get topic. Topic is going to come from our state topic. Then let's say we did all the processing, yada yada yada, and we somehow generated some subtopics. So say subtopics, and that's subtopics will going to be a list, and we're going to have a few subtopics here. So let's say for our topic, we want to research the history. Let's say our subtopic is something like quantum physics, something like that. So we want to research the history. Then once again, we want to research the current trends on that topic. And we also want to look at the future of quantum physics. So future outlook. So we'll take a topic and we'll break it down into history, current trends, and future outlook. So we get those subtopics, and now we can update our state by saying subtopics and giving it these subtopics. So these are generated subtopics for us. Like I said, this operation is dynamic, so you don't know how many of it is coming. We are coding it, so you know it's 3, but typically you don't know how many of this is going to come. The LLM, if you use an LLM to process that, it can generate 5, it can generate 7, it can generate 17. If you pull it from a database, you don't know what is coming. If you pull it from an API, you don't know what is coming. So this is the generation step. We're generating the subtopics. Now we need to research each one of them. We need to create a node to research that, but the node would only be able to research one at a time. Then we need to spin up multiple instances of that node for each of the subtopic. Each of the subtopic represents the private state, the distinct states that will be going into each of the node. But let's write out the node first. Let's write out the research node. The research is also going to be mocked. So here I'm going to say define research subtopic. So that's going to be the name of our state. Now this is going to use the research state. Going to use the research state for its operation, and it's basically going to fetch the subtopic, which comes from state subtopic, and our research is going to be mocked as a simple string. So say f, say research findings on subtopic. So here we just assume that we did some detailed analysis. We got some data in there to prove our point, and we got some valuable insights and many more. So that will just be our research. But typically, this is also something that will be done probably through an LLM or through an API. So you probably use a reasoning model to do the research and get the results, then pass it back into state. So here we're just going to return our results. And now we go with research results. And we're simply going to just pass in results. Passing the result. And because we're annotating it with the add operator, it's just going to append it here, because here we're calling on the main state. So research results, that's fine. Turn it back into state. So it's compiling it in the overall state for us. So once we have that in place, I need to get out of this function. Yeah, good. So once we have that in place, the next thing we're going to do is create the node that is going to compile all the research results, and present it to us. So let's do that next. So here I'll say define compile report. This is also going to take the overall state. And here, we're going to combine all our results. I'm just going to say results equals states. All our results are in research results, so that's where it is. Then we're going to build a report. So first, I'm going to start my report by just having like a delimiter at the top, say 50 lines. Then I'm going to put a new line here. Then the report itself, I'm going to concatenate a title, say comprehensive research report. New line. Comprehensive research report. Then we concatenate another delimiter here. Okay, put that here. And we then build the report. So I'll say for I in results, for I results in, then let us use enumerate to give the results keys, and it should start from 1. Enumerate. You start from 1. What we want to do here is just append stuff to our report. So append the main report itself. And say f string. Then here we have I. Then we have the results. We just put 2. Oh no. We just put 2 carriage return characters. Good. And then we'll break out of this and return the final report. So our compile report node, which is the node that synthesizes all the information, that gathers all the information, is going to go into research results where we have been compiling all our research. Then we build a report. We call it a comprehensive research report. We loop over those results and we just add the individual researches to the report, and then we send it back as a final report. Oh, I'm not done with this. Final report is going to be a report. Yeah. So final report. Awesome. So now we have our nodes. Time for our edges. And like I said, you spin up your send requests from a conditional edge, and we're going to be seeing how to do that now. So I'm going to create that conditional edge and call it continue to research. So after gathering the subtopics, the next thing we want to do is continue to research. It takes in state, and for this we need the overall state because we need to be able to access those subtopics. To get the overall state, and inside here, this is where the magic happens. So we create a list of send requests. So we want to send. I like starting with the for statement for this expression. So I'll say for S in state subtopics. So S in state subtopics would like you to set a send request to the research node, which is research subtopic, and give it the state subtopic because it expects a subtopic. If you look at the schema, it expects a subtopic, and that subtopic should be set to S here, which is our research S here. So we'll set this. Yeah. So we generate a send request for each of the subtopics that was generated with this conditional edge. So that's all we need to do. This is the map operation. Oh, I'm out of that. So let us get out of this. And now let us build our graph. So I'm going to say builder equals state graph. Our graph state is overall state. So put that here. We add our nodes. So we say builder.add node. Just going to add them with their function names. So one for generate topics. Duplicate that. Then we have two more. One for research subtopic and one for compile report. So that's good. Now we need to define our edges, which is where we're going to we'll set up the entire operation. So first, we say builder.add edge. No, add edge. We start, and first thing we do is generate topics. So generate our topics. And next thing, we add another edge. After generating our topics, we then want to go to that condition, which is continue to research. So we go to continue to research. And once we do that, all the research topic nodes should end up at compile report. Should have a compile report. Compile report. And once we're done compiling the report, we can then end. The graph. So we end here. And now let us compile this graph. So I'm just going to say graph equals builder.compile. And then we can test this out. Let's test it out. So test the graph. Test the graph. Okay, that's good. So to test our graph, let us define our initial state first. Say initial state. Our topic. Let's say our topic is artificial intelligence. That's why we're here. Our topic is artificial intelligence. Then our subtopics. For our subtopics, we have none, an empty list. Our research results is also an empty list. And our final report. Our final report is an empty string. Yeah, and a comma there. Final report is an empty string. So our topic is going to be artificial intelligence. So by the time it generates subtopics breaks it down, it's going to be artificial intelligence history, artificial intelligence current trends, and artificial intelligence future outlook. So we have all those in place, and now we can say final state equals graph.invoke initial state. Awesome. Then finally, just as we've always done, print out our final state so that we can see the results that we get from our map reduce operation. So let's save that. And but before let's just print out our final report from here. Let's print out our final report here. Yeah. So do this. Oh yeah, I still have some errors from the last demo. Okay, so we print out our final report from the final state. Let us run this. Python map reduce send demo. Yeah, I hope the demo goes on our side. Let's run this. So we get an error. It says there's a value error. Found edge ending with engine at node, unknown node. Continue to research. Interesting. continue to research. Is there a problem with continue to research? We have a problem with continue to research. Let's see what the problem is. Another research topic. Let's go down, continue to research. Oh. Big. My bad. Also, here I am adding a conditional edge. I'm adding a conditional edge and I'm using add edge. That's a bad mistake. I'm supposed to use add conditional edges. Yeah, add conditional edges. Sorry about that. Add conditional edges. That is what I'm supposed to use here, not add edge. Sorry about that. So let us run this again. Let's clear. Now, demo gods, here we plead. And boom, yeah, we get our result. We get our result this time. So comprehensive research report. As you can see, research finding on artificial intelligence history, research finding on artificial intelligence current trends, and research finding on artificial intelligence future outlook. So we've been able to generate a bunch of subtopics, even though we didn't generate them, but most likely you're going to be getting this from a dynamic source and map it to a node that we spin up like worker nodes. We spin up multiple instances based on the amount of operations we need to perform. At the end of the day, we bring all the information together and synthesize it into a final output. And that's the magic of Send.